Okay, solve trig equations. So last time we did something very similar to this, but I just want to touch on that again just to make sure that we've got that before we start to add complications to it. So sine of x equals a half, where x is an element of 0 through to 4 pi inclusive. Okay, great. Well, let's think about what this is saying. It's saying when does sine equal a half? Now we can type that into a calculator, it'll spit out just one response, but hopefully we know by now that if I go all the way around a circle, then I should get two solutions for this. Worse yet, if I'm going from 0 to 4 pi, that means I go around twice, so I should actually get 4 sets of solutions. Okay, well, we have to think about this a little bit more carefully then. First thing I suggest you do is draw a crappy unit circle somewhere. For me, I'm going to draw this over here. So there's my crap unit circle. I need sine to be a positive result. Okay, well, A and S are up there. Beautiful. Next thing I would have you say is, okay, what's what I'm going to call the critical angle, which is just the angle to the horizontal. So critical angle for this, okay, sine of something equals a half. So you think about the table, where does sine equal a half? That's pi on 6. Okay, great. Well, what does that tell us? That tells us that the thing inside here has to be, amongst other things, 1, 2, 3, 4. And I'm going to suggest that you always do 4 spaces here. You don't have to, you can get away with a whole lot of other things, but I'm going to suggest you do 4 for your baby steps. And I even do this now, just to make sure I don't do a dum-dum. So, what does x equal? Okay, well, this first, so I'm starting at, sorry, I should mark off. I'm going to start at 0. I'm going to move up pi on 6 until I hit my first line. Well, my first one is pi on 6 then. So I'm going to put that here. Okay, great. I'm going to keep going around. That's my next one. Well, where is that? Well, I know this is pi, so I'm short from pi by pi on 6. So pi minus pi on 6 would be 5 pi on 6. Okay, great. And I could go around again. Okay, I will. Sorry, no, I won't. Instead, rather, I'm going to go backwards around the unit circle to get some other ones. Okay, so I start at 0, I go around, I'm at negative pi, and another negative pi on 6, because I'm going in the negative direction. So negative pi minus pi on 6 would be negative 7 pi on 6. Cool, and then I can keep going. This would be negative 2 pi. I need to short that by pi on 6, so that's negative 11 pi on 6. Beautiful. Okay, so we've got that done. Great. Well, this is infinitely many solutions because I can keep this pattern going. Alright, but I want specifically between 0 and 4 pi. Okay. Well, because of that restriction, 0, well, there's my 0, right? All these are negative, all these are positive. Okay, fine. What about other potential solutions? What was it? What? So we'll go red and green, yep, okay. Alright, well, let's think about some patterns that are in here. Hopefully what you'll notice is that these two are 4 pi on 6 apart, and these are 4 pi 6 apart. And similarly, here we're going to get 8 pi on 6 apart. Alright, well that's nice. Why do I bring that up? Let's continue this list going, because we need to get up to 4 pi anyway. 1, 2, 2 more. Okay. Great, alright, so this was pi on 6, then 5 pi on 6. I complete the first lap. I'm going to keep going, so this is 2 pi, add another pi on 6, that'd be 13 pi on 6. Cool, this would be 3 pi minus pi on 6, so 17 pi on 6. Complete that lap, so now I'm at 4 pi. 4 pi plus pi on 6 gives me 25 pi on 6. Great, over to here would be whatever I was up to, 5 pi now. 5 pi minus pi on 6, so I get 29 pi on 6. And I can keep going and going and going. Great. Well, hang on. We wanted to stop at 4 pi. Well, 4 pi is 24 pi on 6, so I should have stopped there. Okay, great. Well, how far apart are these? They're 8 apart. I'll just keep pointing those out. That's 8 apart. That's 4 apart. That's 4 apart. So, unsurprisingly, given that sine is a periodic function, we're getting these repeating solutions appearing. So once you've got some solutions, you can fill out all the rest of them without having to actually count around the circle anymore. The reason I suggest 4 is just so that if you do something dumb, it'll come up that the pattern doesn't work, and then you'll recognize something went wrong. Okay, great. Well, for this question with this restriction, that means that these guys are our solutions. Pi on 6, 5 pi on 6, 13 pi on 6, 17 pi on 6. And that's it. Cool. If you wanted to check, you could type them into a calculator, so you could go sine of pi on 6, should get a half, sine of 5 pi on 6, should get a half, so on, so on, so on. And they should all work nicely. If at any point it doesn't spit out a half, you know you stuffed up. The harder thing to catch in this is the solutions that you miss, which is why I suggest writing them out like this. Okay, well that's pretty straightforward. What if we add some complications to it? Okay, well, this time I've got to look at it and go, well hang on, I need to get this x, but I've got a whole bunch of other things adding extra confusion to it. So just like back in normal algebra, we're going to try to isolate this x. Well, if I knew what x was, I'd times by 3, then I'd take cos of that, then I'd multiply by 2. Okay, well, multiply by 2 was the last thing I'd normally do, so I need to undo that first. So I'm going to divide by 2. Done. At this point, we've got a trig function, and we want to undo that. That's what this unit circle bit's about. So we draw up our unit circle. Oh, that was a bit bad. Let's clean that up. There we go. Cool. I need when cos is a positive. Okay, well, ASTC, so cos is positive there and there. Next bit, I need to know what I'm going to call critical angle is. Okay, when does cos equal root 2 on 2? Well, that's pi on 4. Great. Well, normally I'd write x, but this time I've got 3x in here. So 3x equals ... and I'm going to suggest 1, 2, 3, leave yourself 4 solution spaces. Okay, great. So I need when does cos equal root 2 on 2? Alright, well that's starting at 0. My first one is here, so that's pi on 4. I'm going to put this here, so I always have 2 negatives, 2 positives. Great, go around, that's pi on 4 short of a full 2 pi, so that's 7 pi on 4. Great, that's completed a cycle, great. I want to do the same thing backwards now, so starting at 0, I go backwards pi on 4, okay. And over here would be negative 7 pi on 4. Cool, so I've got 2 positives, 2 negatives. Okay, fine. Now, a lot of people will try to expand this out now, so that I can get up to 2 pi. Just hold your horses for a second there. Because we've got to get rid of this 3 still. So, let's do that now. X equals ... Everything dividing by 3, well that's just going to turn all these 4s into 12s. So 7 pi on 12, pi on 12, pi on 12, 7 pi 12. Okay, great. Well, from here, we want to continue out our list to make sure that we're fit inside here. Do we need to go to the left? Well, no, because we knew that we were starting at 0. These are negatives, these are positives, so straight away, I can get rid of that. Okay, well, how far up this way does it go? Good question. We'll have to do some counting. Okay, well, from here to here, I've got 2 pi on 12. From here to here, I've got 6 pi on 12. Here to here, 6 pi on 12. Okay, so I should get 2, 6, another 2, another 6. Okay, well, let's continue that list then. Oh, that was a little bit snug, but okay. Let's go there instead, that's better. Add 2 gives me 9 pi on 12. Add 6, where should my comma be? It should be here. Add 6 gives me 15 pi on 12. Oops, 12, not 6. Add 2, 17 pi on 12. Add 6 gives me 23 pi on 12. How many have I got? 1, 2, 3, 4, 5, 6. Should do another one. that you won't necessarily know where to stop with this. So you just keep going if you end up short. Well, actually, let's do that now. So I've got pi on 12, 7 pi on 12. Great. I need to get up to 2 pi. Everything's getting divided by 12, so 2 pi would be 24 pi on 12. Okay, we'll keep going, keep going, keep going. 23 pi on 12, so I'm close. I've got to go one more to be sure. Add 2 is 25 pi on 12. Well, hang on, 25 pi on 12 is bigger than 2 pi, so we stop. Okay, great. Well, that means that my solution is pi on 12, 7 pi on 12, 9 pi on 12, but we've got to be careful because that simplifies. 3 pi on 4, 15 pi on 12, 5 pi on 4, 17 pi on 12, 23 pi on 12. So we end up with 6 solutions this time. Now there are ways to know how many solutions you'll end up with before you even start. In this case, we had 3x, so that means the period is you'll get through 3 times as many cycles as normal. The normal would be 2 pi, so normally I'd get through 2 in 2 pi. This is going to happen 3 times as quickly, so I'll get through 3 times as many. 3 by 2, 6. So that's the quick way of doing it. Be careful when you do that, there are limitations to it. So I highly recommend just make sure you do your count and end up outside the end so that you know definitely, yeah, I should stop here. Beautiful. Most of 14H is like that. Don't even think it's even as hard as that. 14J is the next thing that I want you to practice with. It's got more fiddly ones like these ones. The only thing is, it's telling you to sketch. I don't want you to sketch them. I just want you to make all the y's equal 0 and then solve. And then in the answers, whatever the x-intercepts are, those are the solutions you should be getting. No more, no less. Cool. All right, let's keep going with slightly more complications. Okay, great. Well, first thing I want to think about is I need to get this x by itself. What's stopping the x from being by itself? So normal rules, I'd have to minus off this 3 first. Okay, great. What's stopping the x being by itself? Well, this root 3 needs to go, so divide by root 3 and get rid of that. Great. All right, negative 3 divided by root 3. Well, remember that 3 is just root 3 times root 3. Okay, so root 3 times root 3 divided by root 3 should just be root 3. So this all simplifies down to root 3. Great. I've now got a trig function equaling something, so now I need to draw up my unit circle. Tan is negative. Okay, A, S, T, C. Cool. Those are my critical angles. When does tan equal root 3? Well, think about that for a second. Should be pi on 3. Got a lot of 3's in this one. Did I do that the right way around? Yep. Cool. Okay, great. Well, whatever is inside that argument equals ... 1, 2, 3, 4, ... Okay. First positive solution. Start at 0, work your way around. This is pi minus my critical angle, pi minus pi on 3, 2 pi on 3. Cool, going all the way around, 2 pi minus pi on 3, it's 5 pi on 3. Okay, what if I went backwards instead? Start at 0, backwards pi on 3, well, that's just negative pi on 3. Backwards to pi, and backwards another pi on 3, negative 4 pi on 3. Beautiful, so we've got a set of solutions, okay. We need to divide everything by this 4. ... Now I'm going to leave this like so, just so that there's less work. You could simplify now, but commonly that'll lead to errors, which don't particularly help. And also it makes the next bit hard. So we want to figure out what the gaps of this are, which I'm going to do in pink this time. So that's a gap of 3, that's a gap of 3, that's a gap of 3. This should happen for tan. You should always get a consistent gap. Sine and cos, you'll get an alternating gap. Tan, you'll get a consistent gap. Beautiful. Well, that makes it easy to fill in the rest. we need to get between negative pi and pi this time. Okay? Well, if we fill these in, we're minusing another 3. So, we'll give that some space. Well, actually, no, we won't. So I'll just keep counting by 3. So 4, negative 4, sorry, minus another 3 would be negative 7. Minus another 3 would be negative 10. Minus another 3 would be negative 13. But 13 on 12, that's bigger than this. So that's no good to me. So I need to go back to whatever the last one was I said, negative 10. Pi on 12. Up another 3, negative 7 pi on 12. Up another 3, negative 4 pi on 12. Keep going. And if we add another one here, we get 14 pi on 12, but that's bigger than pi, so stop. Okay, great. Last bit, we're just going to simplify this. So that divides by 2. This doesn't move. This divides by 4. That stays. Pi on 6, 5 pi 12. That's a 5. There we go. Divide 4. And stays. Beautiful. Notice now that we've got thirds and sixths and twelfths, right? This is getting all really messy, which is why it's usually a good idea to keep everything the same denominator until you get to your final answer. Beautiful, we've got 1, 2, 3, 4, 5, 6, 7, 8 separate solutions. Well, if we think about this for a second, negative pi to pi, that's still a gap of 2 pi, so it's as though we've gone around the circle once. Okay, we're doing everything 4 times as quickly, so we get 2 solutions per lap, and we're doing 4 times the number of laps, so that's 8 solutions. That's how many we ended up with. That seems reasonable. Beautiful. That's that. So, like I said, for the 14H, it'll be nice simple ones like this. For 14J, you'll get things something like you'll have A times some trig of something. Oh, we never did. We'll do one more example actually. 2 of sine of 3x minus, let's say, minus a pi. Let's go, what did we do before? So we'll go plus this time. Oh, we'll do pi on 4 because that'll make things more interesting. We can have one of each of the first numbers. Lovely. Equals, say, y. So you might get questions like this. Okay, great. What I want you to do for this round is just make this equal 0. And the reason we're doing that, we're finding x-intercepts. At x-intercepts, y equals 0. Next time we'll do the full graph, but for now we just need to find x-intercepts. Okay, great. Well, what are we going to do? We're going to have to manipulate this. So first thing that's going to move is the 1. Then we're going to have to divide by the 2. So sine of 3x minus pi on 4 equals negative a half. Great. We've got a trig function, so now we've got to draw the unit circle because we can't move anything else. Sine is negative, ASTC. Cool, critical angle. When does sine equal a half? That'd be pi on 6. So the inside equals, oh, I never gave this a domain. Let's give this a domain of, let's say, how fast is it going to go? Go negative pi on 2 to pi on 2. Actually, let's go 3 pi on 2, just to make it more interesting. Yep, okay, cool, all right. So dot dot dot, 1, 2, 3, 4, dot dot dot. Okay, first solution going in the positive direction. So I've got pi plus another pi on 6, 7 pi on 6. 2 pi minus a pi on 6, 11 pi on 6. Going backwards around the circle, negative pi on 6, and negative 5 pi on 6. Cool. Now for the most annoying part, whenever you've got these little phase shifts, we're going to have to add pi on 4. Well, that's going to suck because now we're adding quarters to sixths. So instead, I'm going to change them to be out of 12 before I do anything else, simply because everyone has dum-dum moments with fractions, so let's avoid that happening in the first place. 2 pi on 12, 14 pi on 12, 22 pi on 12. Now you don't have to do this, you can go gung-ho and stuff it up if you want, but I'm going to highly recommend that you don't. A little bit of caution helps a lot. Cool. So, adding 3 pi on 12 to all of these, now I don't have to fiddle around with fractions, I'm just adding 3 to the top of everything. Be careful, I've got add 3 to negative 10, so negative 7 pi on 12. Add 3 gives me pi on 12. Add 3, 17 pi 12. 25 pi on 12. That blue's starting to die off. Okay, excellent. Well, next thing I need to do, divide by this 3. Okay, we'll divide by the 3. Well, that's negative 7 pi on 36, and the same with the rest. Fantastic. Okay, last thing, we need to restrict the domain. Okay, well, I need to fill this out a bit further so that I know when I've actually crossed over that line. Okay, well, let's fill it out by figuring out what our gaps are. These two colours. Okay, so we've got big gap 16, little gap 8. Big gap 16, little gap 8, big gap 16, little gap 8, big gap 16, little gap 8. Okay. Okie dokie. Adding, well, minusing 16 since we're going that way gives me what, negative 23? Is that right? Yep. Negative 23 pi on 36, which we're already good. Okay. Well, minus another 8, why not? Minus 31 pi on 36. That was that one, that was that one. This one's just sitting pretty. 36, 17 pi on 36, 25 pi on 36. Cool. Add 16. Gives me 41 pi on 36. What are we going up to? Yep. That's that one. Add another 8 to that. 49 pi on 36. Add another 16. These are getting a bit wonky, but okay. What did I say? Add another 16. 50, 65 on 36. Yeah, we'll go with more. 8 is 73 pi on 36, and we could keep going, but we shan't. We're going to fix up these gaps, 8s and 16s. So what was that? That's to there. This to here is 8. This to here is 8. This to here is 16. Yep. Beautiful. Okay, well now we've got all these. Okay, negative a half pi, or negative pi on 2. Well, that's positive. That's negative. Okay. 7 on 36, that's smaller than a half, so he's okay. 23 on 36, oh, hang on, that's bigger than a half. So, pretty sure, hang on, let's double check that. 15 and 3 is 18, yeah. So that's no good to me, I need to chop that off. So these guys aren't part of my solution. I need to go up to 3 pi on 2. Okay, I'm out of 36, so it might be worthwhile to say this is negative 18 pi on, oh wait, sorry. Yeah, negative 18 pi on 36. And whatever this is, 54 pi on 36. Okay, 54 pi on 36 is right there. So these two are not part of my solution. Great. 1, 2, 3, 4, 5, 6 sets of solutions. Okay. The distance between these is 2 pi, so that's one complete cycle. So we're expecting 2 solutions times the 3, because we're going through everything 3 times fast, which would be 6, 2, 4, 6. Beautiful, we got our solution set. Fantastic. That's about as complicated as it gets. This is very fiddly the first couple of times you do it, and it is very easy to stuff up, particularly on the negatives and the fractions shifting. So I highly recommend do things slowly, stage by stage, just like I've set out there. As soon as you try to take shortcuts, it'll usually bite you. So be super careful, 14H is just complete the sheet. It's mostly those sort of simple ones, so that'll give you a bit of basic practice. 14J, just turn all of the Y's into zeros, and then solve those, and then the answers are the Y-intercepts on the graphs. So that's that. If you've got any troubles, do email me, otherwise cheerio.